In my video on sweeteners, I mentioned a scientific paper that had some surprising findings. I want to briefly present this data, but I also want to use this paper as part of a continuing series on how to interpret a scientific paper, even if you aren't a scientist. In recent years, most journals are online and offer either pay-for-use or free online PDF versions of content. I prefer the Medline resources that are hosted at the National Center for Biotechnology Information, or NCBI. The widest search is called PubMed, and it includes a mix of pay-for-use and free articles. However, a PubMed central search will only return the freely available full-text articles. That's where I found a version of this paper, available as an article in Press. The journal is Pharmacology, Biochemistry, and Behavior, and it's published in 2010. The authors are from Princeton and Rockefeller, and they are psychology or behavioral neurobiologists. This is an important piece of information, as we'll soon see. There are at least 4 major sections to every paper. The abstract, which summarizes the key points in the paper. The introduction, which gives background to people not familiar with the field. It will be heavily cited since it describes the work in the field relevant to the current study. The methods section, which describes how the study was conducted. The results section presents the outcomes of tests run. This is where you'll usually find the graphs and charts. And the discussion, which is usually followed by a conclusion or concluding paragraph. This is the most subjective part of the whole paper, where the authors can give their interpretation of the results. You'll also find acknowledgments and a long list of references to other papers used to support points in the paper. In particular, you should keep an eye out for funding sources, which are listed in the acknowledgments. This group, for example, have previously been funded by PepsiCo. I personally make it a point not to dismiss research that is well published, even if there is an apparent conflict of interest. It adds to my skepticism of the results, but I think it's a slippery slope to reject research because of who conducted it. On to the paper at hand. I'm going to go through how I typically read a paper. I always start with the abstract because I need to know if the article is relevant. I scan through the details, which gives a preview of the study. I note that this compares HFCS to sucrose, and that they find a difference between the two. Here's the statement that really catches my interest. Rats with 12-hour access to HFCS gain significantly more body weight than animals given equal access to 10% sucrose, even though they consume the same number of total calories, but fewer calories from HFCS than sucrose. The last statement is, translated to humans, these results suggest that excessive consumption of HFCS may contribute to the incidence of obesity. I usually read the introduction quickly or skim it because it's usually a summary of prior work. In this case, they summarize the nature of the problem of obesity and how sweeteners have contributed to that. They also highlight the lack of studies directly comparing sucrose and HFCS. On to the methods. There are 3 experiments in this paper. The methods section is broken down accordingly. Experiment 1 compares weight gains in males-only rats. Note the population size, which is relatively small, 10 rats per group. All the rats are given as much rat chow and water as they want. Group 1 gets no sugar, that's our control. Group 2 gets 24-hour access to HFCS solution. Group 3 gets only 12-hour access to HFCS, and Group 4 gets 12-hour access to sucrose solution. They explain that the HFCS contains fewer calories and is designed to match sodas. The sucrose is 10% solution and likewise matches sucrose-containing sodas. They live the standard American lifestyle for 8 weeks, then go to the great Swiss cheese in the sky, and their bodies are weighed and other factors measured, including the pads of fat found around their rat tummies and just under their rat skin. I want to draw your attention to the group 3 here, the ones that get only 12 hours access to HFCS. It's key to understanding this experiment. There's a citation to Avena et al. 2006. which is also available free online, and a very interesting paper that compares addiction to sweeteners to addiction to drugs. Remember that these are behaviorists or psychologists, and the results we will get for Group 3 will be the most surprising. I'll come back to it in a minute. The other two experiments are less useful for my purposes, so I'll summarize them quickly. Experiment 2 was male rats, and it excluded the sucrose group from Experiment 1. They measure the results of varying access to rat chow and HFCS. So some rats had 24-hour access to chow, some had 12. Others had 24-hour access to HFCS, others had 12. Experiment 3 is simply adding female rats to this experiment to allow for the measurement of sex-specific effects. This particular type of rat, called Sprague Dawley, has a very noticeable difference in size between males and females at adulthood. Remember that good science is always testing one variable at a time, controlling for every other untestable variable element. In reviewing this paper, I spot a lot of ways that they failed to control for multiple effects of testing. The results of the testing are interesting and can be nicely summarized by Table 1. This is the final body weight after 8 weeks of modified diet. The weight is in grams, and the plus and minuses are the range of weights obtained. A little star next to the value indicates that it was a significant change. That means something very specific in statistics, which we biologists usually summarize as saying that the probability of getting these results by chance is less than 5%. So, according to this chart, rats who only had 12-hour access to HFCS got significantly fatter than the other groups. But I think it's worth noting that the effect is relatively small. So let's remember that this was a behavioral effect when animals only had limited access to HFCS. It was an addiction and tolerance behavior. The animals indulge in binging when you take away their sweeties. Even though they actually drank fewer calories of the HFCS, that behavior of binging appears to have increased their weight ever so slightly. The effect was more pronounced than with sucrose, although you may note that the 12-hour access to sucrose mice were heavier than the 24-hour access to HFCS mice. What I take from this is that sweeteners that stimulate sugar binging, which remember is a bit like what sugary sodas might do to humans, are likely to cause weight gain, but HFCS might stimulate this slightly more than sucrose. This is the fact I can't quite explain, and it's very intriguing. I suspect that the small chemical difference between HFCS and sucrose, specifically the 9% lower glucose, is what's causing this effect. There's more of a dysregulation of blood glucose. The only way to confirm this would be to test it. The other experiments are interesting, but with the sucrose group removed, it's just more of an indictment of overconsumption of sweeteners and the negative effect of fructose on obesity and lipid profiles. I'll leave it to you to read these sections and make sense of them. Section 4 is the discussion, and its somewhat subjective interpretation of the results. The authors reflect on the finding and try to synthesize them into the body of literature on the topic. I'm skipping over a lot of information in the interest of time, straight to 4.5, differences in sugar and metabolism, the area I found most interesting. They first proposed some mechanisms for the difference in weight gain between sucrose and HFCS, lipid metabolism, fructose content, the rates of breakdown, liver transport. When I read this, though, I'm struck by a mismatch. Remember the comparison in Experiment 1. We had sucrose with 12-hour availability and HFCS with 12 or 24-hour availability. The 12-hour group showed the effects of addiction to sweetener, binging. But the 12-hour group for sucrose compared to 24-hour HFCS showed about the same weight gain. At most, I would say that HFCS may trigger more of a behavioral effect, and that's something I would like to see tested further. I'll give the authors the final word. Section 5, Conclusion. In summary, rats maintained on a diet rich in HFCS for 6 or 7 months show abnormal weight gain, increased circulating triglycerides, and augmented fat deposition. All of these factors indicate obesity. Thus, overconsumption of HFCS could very well be a major factor in the obesity epidemic, which correlates with the upsurge in the use of HFCS. Thanks for watching.